Quat is short for quaternary ammonium compounds and is sometimes written as QAC in literature, but more often it's shortened to Quat, spelled QAT in conversation. There's your answer. More than a century ago, quaternary ammonium compounds were discovered to have antimicrobial properties. Today, Quat is commonly used to clean non-critical patient care equipment. Let's briefly talk about the history of Quat. Why do we use Quat to disinfect things, and how did we come to use it in that way? It all started over a century ago when people found that Quat has germicidal properties in 1916. Almost 20 years later, in 1935, the first commercial Quat-based disinfectant product was invented and brought to the cleaning and disinfection market. Then another 20 years later, the synergistic efficacy that comes from the combination of Quat with alcohol was discovered in 1955. It was known at that point that alcohol has antimicrobial properties as well. The beauty of combining the two germicides together is that the disinfectant becomes much more powerful. A single Quat ingredient on its own isn't able to deactivate difficult pathogens, such as TB. But when mixed with even a small amount of alcohol, that's when the magic happens.
The problem with quaternary ammonium compounds is there's a lot of scientific literature that shows that they're harmful. They're harmful to the environment. There's ecotoxicity. They're ranked very high in ecotoxicity. They've been shown in laboratory animals to cause birth defects. They've been shown to cause infertility in lab animals. And you know, that's what we're using. And really, during the pandemic, that cleaning regimen has gone through the roof, right? What you used to clean 3 times, now you clean 10 times because you're really worried about these germs. So the quaternary ammonium compounds, they've been billed as safe, but in the European Union, they've banned them from hand washes. They've banned them from body washes over safety concerns. They've been grandfathered in for a really long period of time, so people assume that they're safe. But especially now with the cleaning regimens accelerating, people are getting exposed to a much higher level. They know that it causes asthma in humans. That's a known fact. Look, all these people are cleaning all these buildings with things that are potentially toxic, and they don't know about it. And that's a problem. That's something that needs to be addressed. So when we started doing our studies in the lab, we would cross-compare with quaternary ammonium compounds and our compound. What we found was that in the laboratory, the quaternary ammonium compounds performed really, really well. They looked fantastic. There was no doubt. When we took them into the real world, they don't perform well. And so that's something that the public hasn't been made aware of. And when I say they don't perform well, they perform nowhere near the level that they do in the lab. And that's because in laboratory conditions, everything is clean. Everything is really, really sterile. Everything is tightly controlled. But when you're working in an environment, there's dirt, there's grime, there's oils, and these things affect the efficacy of quaternary ammonium compounds. So a lot of people are going out and they're cleaning these things and they think that it's all clean, but in reality, the efficacy of those compounds goes down significantly. And that's why a lot of times with quaternary ammonium compounds, they'll say, clean this surface really, really well before you put it on. Well, if you don't do that, the actual antibacterial and antiviral effect goes down by logs.
So welcome, my name is Jason Church, Chief of Technical Services at the National Center for Preservation Technology and Training. And today we're going to talk a little bit about cleaning biological growth from grave markers. So the actual cleaning process is super simple. So we're going to focus a little bit on sort of tips, techniques, tools, things like that to be used. Now, since what we have here is just biological growth, a little bird droppings, some insects droppings, we're going to use a cleaner that's a biocide. Today we're going to use D2, which is a surfactant with a biocidal additive. So it's a detergent that also kills biological growth. So for this, we're going to spray the stone down. We want it to let it dwell. So ideally, we're going to spray it, let it sit about 15-20 minutes, let it do its thing before we come back to scrub. And this is when we would go on, do the next one, spray the next one, and get a series of these going. Now you can definitely use a pump spray bottle like this one, or I usually just put it in a garden sprayer and keep separate which one's your cleaner and which one's your water. I usually write the cleaner on it and then put blue tape for water. Now you'll notice our stone is starting to turn colors. That's the biocidal additive in the D2 killing the biological growth that's on the stone. All these things are normal, all that's going to rinse away, but that tells us our cleaner is doing its job.
Chemicals found in popular household products potentially linked to autism, multiple sclerosis, study suggests. By Ariana Johnson of Forbes magazine. March 25, 2024, 12:22 p.m. Eastern Daylight Saving Time and updated March 27, 2024, 8:07 p.m. Eastern Daylight Saving Time. Top line, 2 chemicals found in common household products like disinfectants and furniture may play a role in the development of neurological disorders like autism and multiple sclerosis, according to a new study, adding to previous research that found the chemicals may be detrimental to human health. Key facts: the researchers examined over 1,800 common household chemicals, which they believe lacked research on their potential link to brain health, and discovered 2 that may have a negative effect on brain health. Quaternary ammonium compounds, also called Quats, or QACs, and organophosphate flame retardants, according to the new study published Monday in Nature Neuroscience. Quats are found in products like body washes, fabric softeners, shampoos, sunscreens, baby wipes, shaving creams and disinfectants like some Clorox and Downy products. Organophosphate flame retardants are found in electronic devices, building materials and furniture via flame retardant foam and plastic, according to the environmental advocacy program the Green Science Policy Institute. Quats cause oligodendrocytes, brain cells that generate the protective layer around nerve cells to die. Research shows disrupted oligodendrocytes production is tied to neurological disorders like multiple sclerosis and autism, so the study researchers believe they've uncovered a previously unrecognized risk factor for neurological disease. Paul Tassar, study author and a director at the Case Western Reserve University School of Medicine, said in a statement.
Invented. This has been around for over 20 years now, and this is safe to use on all stones, so you don't have to identify what kind of stone it is. It's not going to have a harmful effect to any kind of stone because it's not cleaning with acid, it's cleaning with more like what I say chemistry, and so it's quaternary ammoniums are the active ingredient, but it's already in a high solution, so we can just spray it directly on the stone. And these little quart sprayers are good to clean a couple stones. Now, in the gallon container, which I just emptied, and I do have more, it is the same product, okay, as the quarts, and they're all ready to use. We don't have to dilute it, so I just poured the gallon into this, and this way I can apply it much more quickly, and we're gonna just spray the whole stone. Now, with all of the highly eroded stones here, we have the option, which would be probably the best thing to do in many situations, is just to apply it and walk away, and it's going to slowly clean. And what's going to happen is that every time, first we're going to get, I'll just back up a little, we're going to apply it to the stone, and some of it's going to get drawn into the stone. And this is the same reason you don't want to use bleach, which is always a harmful thing on historic stone, but that it'll get drawn in, and then with, like, say, a bleach, it'll have future damage to the stone. But the way the D2 works is that the quaternary ammoniums especially get drawn under the surface, and then it will have a residual effect cleaning it from the inside out. And so picture a stone like this, a marble stone especially that's weathered, it's very porous. It's like a sponge. And so it draws in everything you put on it, okay? So you don't want to put things that are harmful on it. Now the other thing is, we don't want to pressure wash a stone like this. We could clean it very quickly, but it'll take off the biological staining with a little bit of stone, and so there'll be less left. And so we don't want to use wire brushes on the inscribed face of the stone, because it'll have the same effect. It'll clean it quickly, but it'll be diminishing what's left. And so what we see occurring here right now, when I sprayed it on, all we need is an application just like that, is we see a color change occurring. And we have kind of termed that a color bloom, and you can kind of liken it to like leaves on deciduous trees changing colors before they fall off the trees. It's a different mechanism chemically, but it's a similar phenomenon, because it's a color change that is preceding the die-off of the biological growth.
Quaternary ammonium compounds, QACs, a large class of chemicals that includes high production volume substances, have been used for decades as antimicrobials, preservatives, and anti-static agents, and for other functions in cleaning, disinfecting, personal care products, and durable consumer goods. QAC use has accelerated in response to the COVID-19 pandemic and the banning of 19 antimicrobials from several personal care products by the U.S. Food and Drug Administration in 2016. Studies conducted before and after the onset of the pandemic indicate increased human exposure to QACs. Environmental releases of these chemicals have also increased. Emerging information on adverse environmental and human health impacts of QACs is motivating a reconsideration of the risks and benefits across the life cycle of their production, use, and disposal. This work presents a critical review of the literature and scientific perspective developed by a multidisciplinary, multi-institutional team of authors from academia, governmental, and nonprofit organizations. The review evaluates currently available information on the ecological and human health profile of QACs and identifies multiple areas of potential concern. Adverse ecological effects include acute and chronic toxicity to susceptible aquatic organisms, with concentrations of some QACs approaching levels of concern. Suspected or known adverse health outcomes include dermal and respiratory effects, developmental and reproductive toxicity, disruption of metabolic functions such as lipid homeostasis, and impairment of mitochondrial function. QAC's role in antimicrobial resistance has also been demonstrated. In the U.S. regulatory system, how a QAC is managed depends on how it is used, for example in pesticides or personal care products. This can result in the same QACs receiving different degrees of scrutiny depending on the use and the agency regulating it.